We are starting now the paper of mechanics 2015 May June. Total time is 1 hour 15 minutes and the total marks are there 50. We are starting one by one question of this. So these are the instructions given in the beginning of that paper. Paper 1 M1 9709 oblique 42 May June 2015 1 hour 15 minutes is the duration and total marks of this paper is 50. And the first question is one end of a light inextensible string is attached to a block. The string makes an angle of 60 degree above the horizontal and is used to pull the block in a straight line on a horizontal floor with an acceleration of 0.5 meters per second square. The tension in the rope is 8 Newton. The block starts to move with a speed of 0.3 meters per second. For the first 5 seconds, the block motion, find the distance traveled, part 1, and part 2, find the work done by the tension. Since the block is on the horizontal floor and it is being pulled with a tension of 8 Newton, making an angle of 60 degree with the horizontal with the initial speed of 0.3 meters per second with an acceleration of 0.5 meters per second square. Now, you are going to resolve these components into two parts. One is t sine theta and one is this t cos theta. This is the normal reaction to that r. This is the weight of that object and this is the frictional force acting on that object there. And the total time there is 5 seconds. We know that we are going to calculate the total distance traveled. Since we have this formula, S is equal to ut plus half at square because it is on the horizontal surface. So we are going to use the S acceleration. So S is going to be equal to U is there 0.3, time there is equal to 5 plus half, acceleration there is 0.5 into time there is 5 square. This will become S is equal to 7.75 meters. So this is the distance traveled by that particle there. Second part is work done by the tension you are going to calculate. Since we know that there's only this force is going to act on that particle, which is the driving force. So work done due to the tension is basically equal to T cos theta, that is a force, into displacement, that is equal to 7.575 meter there. Now we can put the values into this. Tension there is 8 cos of 60 into 7.75. So 8 cos of 60 is 1 over 2 into 7.75 and that will be equal to 31 joules. Because joule is the unit for this work done due to this tension of that force there. So these are the two parts of this question number 1, which we have solved it. First, we have calculated the distance, and then we have calculated the work done due to the tension of that string there. Now, question number 2. The total mass of the cycle and the cyclist is 80 kg, and the resistance to that motion is 0. The cyclist moving along a horizontal straight road working at a constant rate of Pw. Find the value of P given that the cyclist speed is 5 meters per second when the acceleration is 1.2 meters per second square. The second part of that thing is the cyclist moves up the straight line inclined at an angle of alpha, where sine of alpha is equal to 0.035. Find the acceleration of the cyclist at the instant when he is working at a rate of 450 watts, and the speed of that one is 3.6 meters per second. So we use this power formula there. We know that power is equal to driving force into velocity. But driving force minus resistive force is equal to ma, because cyclist is going to move on this horizontal track there. So driving force we are going to calculate. There's no resistive force. Mass of that particle is 80 into acceleration of that particle is 1.2. So that thing is equal to 96 Newton. Now, power is equal to driving force into velocity. So this will become 96 into velocity there is equal to 5. So that value is equal to 480, and it is because units of this is watt. So 480 watts will be the power of that car there, cyclist there. The second part of this the cyclist is moving up the straight hill which is inclined at an angle of alpha. The acceleration of that instant is this power is 450 and the acceleration is 3.6. Now this is cyclist there. So we will resolve it into components. This is R of this. This is mg cos of alpha. This component is mg sine of alpha. This is the driving force of that, and that is the resistive force, which is in the form of friction there. But since it has no friction, so we will use this force is equal to 0. Now, we know that driving force minus resistive force is equal to ma. but there's given power there, and their speed given there is 3.6. So we know that power is equal to driving force over velocity. So this means driving force will be equal to power there is driving force into velocity. So this means driving force will be equal to power P over V there. So we have calculated the value of P, that is equal to 450 divided by V there is 3.6. So that is the driving force of this. Now we put this value into this main equation of this 1. So driving force is basically equal to 450 over 3.6 minus the resistive force there, because itself there is no friction, but there is mg sine alpha is also with this resistive force, and that thing is equal to m into a mass of that acceleration is, we have calculated already there, which is equal to 80 kg. So this will become 450 over 3.6, mass is 80, g is 10, sine of alpha is already given to you 0.035, mass of that particle is 80 into acceleration a there. So we can calculate the value of a is equal to 1.21, and the units for this one is meter per second square. So this is the second part of that question, which is used in this part there. Now question number 3. A plane is inclined at an angle of sine inverse of 1 over 8 to the horizontal. A and B are 2 points on the same line of the greater slope, with A higher than B. The distance AB is 12 meter. A small object P of mass 8 kg is released from the rest at A and slides down the plane, passing through the point B with a speed of 4.5 meters per second. Find for the motion of this P from A to B, first part, the increase in kinetic energy of the P and the decrease in potential energy of P. And the second part is the magnitude of the constant resisting force that opposes the motion of P. Now, they are asking two things in the first part. This is A is higher than B. It starts from rest. AB distance is 12 meter. And at B, when it is going to pass at that point, its speed is 4.5 meters per second. So they are asking the gain in kinetic energy. We know that the gain in kinetic energy will be equal to half mv square minus half mu square. Half mass is 8, v is there 4.5 square minus this 0 because initial density is 0 there. So it will be equal to half into 8, that is 4 into 4.45 whole square, and that value is equal to 81 joules, because energy is measured in joule units. Second part is loss in potential energy. But we know one thing, then the particle at this position, let's say this height is 12, A is higher than B. This is angle theta there, which is equal to sine inverse of 1 over 8. This is, let's say, the height. It has decreased in that value from A to B. And now we will calculate this height. H over 12 perpendicular over hypotenuse is equal to sine of theta there. So H is equal to 12 sine theta. But here H theta is equal to H sine inverse of 1 over 8. So sine of theta is equal to 1 over 8. So it will be equal to H is equal to 12 into 1 over 8, and that thing is equal to 3 over 2 is meter is the height. It has fallen from A to B there. And potential energy is basically equal to mgh. Now mass is there of that particle is equal to 8. G is there 10 and height is there 3 over 2. So that value is equal to 8 5s are 40, 3s are 120. So it has lost 120 joules in the potential energy of that particle there. Now the second part of this, they are asking the magnitude of the constant resistance force. This we have to calculate from that part. We know that driving force minus resistive force is equal to ma. This is the equation we are going to use for this resistive force motion there. But for that, driving force is what, when the particle is at this position, it is coming downward. So mg sine theta is the driving force of that particle there, minus the resistive force we are going to calculate for that portion there, is equal to m is known to us, that is 8 kg, and acceleration a is unknown. So it means first we are going to calculate the value of a of this portion. So this is equal to, we know that v is equal to u plus at, but time is not known to us. So we will use the second, 2as is equal to v square minus u square. You know the value of 2, a we don't know, s is 12, v square is 4.5 square minus u square is equal to 0. So a value is equal to it is equal to 0.844 meters per second square. Now, driving force is basically mg sine theta, because that is the driving force acting on that particle there, minus the resistive force, we are going to calculate it now, is equal to mass into this acceleration a there. So m is there 8, g is there 10, sine theta is 1 over 8, minus resistive force as it is, we are going to calculate. Mass of that particle is 8 and acceleration is equal to 0.844. So resistive force will be equal to 10 minus 8 into 0.844. So that resistive force is equal to 2.248 3.25 Newton is the resistive force to that motion there. So this is question number 3 we have solved. And now we are starting this question number 4. Question number 4 now. A particle P moves in a straight line at t seconds after start from the rest at the point O. On the line, the acceleration of that particle P is a meters per second square, where a is equal to 0.075 t square minus 1.5 t plus 5. Find the expression for the displacement of this particle P from O in terms of t. Hence, find the time taken for this particle P to return to this point O again. So we are going to find out the displacement in terms of t, but they have given the acceleration in terms of t there. But we know that if we integrate acceleration with respect to time, then it is going to give us the velocity. And if we integrate velocity with respect to time, then it is going to give us the displacement. So these are the two equations which we are going to use it here for the displacement and the velocity there. So acceleration is basically equal to 0.075 t square minus 1.5 t plus 5. Since it starts at O, so that means displacement is 0 at O, time is 0 there, and the velocity is 0 there. So we will use these conditions in this part there. So velocity will be equal to integration of 0.075 t square minus 1.5 t plus 5 into dt, and that is going to give us the velocity. So velocity will be equal to 0.075 t cube over 3 minus 1.5 t square over 2 plus 5t plus constant of integration a there. But to get the constant of integration, we know that the velocity is 0, displacement is 0, and time is 0. So this velocity is 0, time is 0 there. So the constant of integration a is also 0 there. So the velocity will become now equal to 0.075 t cube over 3 minus 1.5 t square over 2 plus 5t. So this is the expression we got for the velocity there in terms of t. Now they are asking the displacement, and displacement is equal to the integration of the velocity there. So x is equal to integration of velocity, that is 0.075 t cube over 3 minus 1.5 t square over 2 plus 5t dt. And that will be equal to 0.075 over 3 into t power 4 over 4 minus 1.5 over 2 square into t cube over 3 plus 5t square over 2 plus a constant of integration b there for this new integral there. But again, we put this same condition, x is 0, t is 0. So if we put x 0, t 0, then b is also equal to 0. So finally we got this expression of displacement there, x is equal to 0.075 over 3 4s are 12 into t power 4 minus 1.5 over 2 these are 6 t square, sorry, t cube, plus 5 over 2 t square. So this is the answer of this whole equation there, that find the x in terms of t there. Now when it returns to O, find the value of t there. So we know one thing there. Then when it returns to O, that means it is going forward, and then it is going to make a turn towards that point there. So that means what? Again at O means that x is equal to 0 for this point again at O there. So you put x equal to 0. So that is equal to 0.075 over 12 t power 4 minus 1.5 over 6 t cube plus 5 over 2 t square. Now you can make it a standard quadratic form of this equation. So we will solve it one by one in the steps there. This will come 160 is the LCM. Then it should be equal to T4 minus 40T cube plus 80 into 5, 400 into T square. And that thing is equal to 0. And this will become T4 minus 40T cube plus 400 T square equal to 0. If T square is taken to be common, then it should be T square minus 40T plus 400, and that thing is equal to 0. Now, either T square is equal to 0, this means time is equal to 0, or T square minus 40T plus 400, that is equal to 0. So it is T square 400 20. So 20T minus 20T plus 400 equal to 0. T minus 20 into T minus 20 equal to 0. This implies that T is equal to 20. So that is 20 seconds, because 0 is the starting point over there. The other time for that is T is equal to 20 seconds is another time when the particle will be at O again there. So this is the complete solution of this question number 4 there. Now we are starting the next question to that part. A particle P starts from rest on the horizontal straight line. Particle P is moving with a constant acceleration and reaches a point A on the line with a speed of 30 meters per second. At that instant, P leaves on Q. O. A particle Q is projected vertically upward from the point A with a speed of 20 meters per second. Subsequently, P and Q collides at the point A. Find the constant acceleration of the point P and the distance OA. Question number 5 now. Let's say the particle is starting from O. That is a particle P there. So starting rest, that means that u is 0 meters per second. When it's reached this point A, the speed of that particle is 30 meters per second. With a constant acceleration A there, and you are going to find out the acceleration of A for this first part there. But at the same time, the particle Q is going to release from this point O, moving upward, and it is going to reach at the point A there. So this is the particle Q, which is moving upward with the speed of 20 meters per second. So this is the information given to us. U is 0, V is 30 meters per second, and the other particle Q is going to be projected from this point O. So first of all, they are going to calculate the value of this acceleration A there. But we know that acceleration of A, we can use this equation because it is motion is on a straight line. V is equal to U plus AT. V is 30, U is 0. Acceleration we don't know. Into the time is also not known to us. So it means we are going to first calculate the time t for that part there. But we know one thing, that the other particle q is being projected upward with a speed of 20 meters per second. So we can make this equation that if it is q moving upward with the speed of 20 meters per second, it is O there. At the highest point when it will reach, the speed of that particle will be equal to 0. And it is going to have this height h there. And the time taken is from O to, let's say this point is B and this point is O. So O to B time we are going to calculate. So from O to B, we know that V is equal to U plus GT because it is moving upward. So it will be U minus GT. V is 0 there. U is 20 minus G is 10 into T there. So T is equal to 20 over 10. That is equal to 2 seconds from O to B. And from B to A, it is the same time. So the total time taken for this particle Q there is equal to 2 plus 2, and that is equal to 4 seconds. At the time 4 seconds after this O, the particle Q is going to meet with the point A. So that means what time taken there is equal to 4. So we can use it here. 30 is equal to A is equal to, don't know, time is there 4. So A is equal to 30 over 4. So that is equal to 7.5 meters per second square is the value of that acceleration there. The second part is find the total distance traveled for this particle P from O to A. So OA is basically equal to the distance, let's say it is equal to denoted by S, then S is equal to UT plus half AT square because it is moving on the straight line there. So U is equal to 0 plus half. Acceleration we have calculated equal to 7.5 into time there is equal to 4. So S is equal to 4 fours are 16 over 2, 8 into 7.5. So that thing is equal to 60 meter is the distance of this particle O to A there. So this is a solution of this question number 5 of this. Question number 6 now. Two particles P and Q have the masses m kg and 1 minus m kg respectively. The particles are attached to the ends of the light insensible string which passes over a smooth pulley P, which is held at rest with the string taut with both strings parts of the strings vertically P and Q are each after the height of h meter above the ground. There is a figure given 1. P is released and Q is moving upward. So Q is moving downward. Subsequently, Q hits the ground and comes to the rest. Particle P shows in the figure 2 vertically timed graph of this P and Q moving downward R is at rest on the ground there. Find the value of H, find the value of M, and also find the values of the tension in the strings while Q is moving. Third, the strings of the slack is slack now while Q is at rest on the ground. Find the total time taken for this particle P to release until its strings becomes taut again there. So this is the complete question of this question number 6 of this paper there. Now we have to find out the height h of that first part. Since we know that they are at the same level at height h from the ground, so its mass is 1 minus m kg and its mass is m kg. And they have mentioned it that Q is moving downward and P is moving upward. But when Q hits the ground, it means it has covered an height h meter above the ground there. And we are going to find out the height h of this particle there. From this graph, we have seen it there. It is a graph of this point P, which is from 0 to 0.5 seconds. It is moving up till a speed of 2 meters per second. And then it comes downward and it is -2 after some time t there. So we know that if we use the first equation of motion, V is equal to u plus at for this particle P there, then V is there 2, u is there 0 because it starts from rest, A is unknown, and the time is 0.5 there. So A is equal to 2 over 0.5. So that is equal to 4 meters per second square. That is the acceleration of that particle Q when it's going to hit the ground there before that. Now, we know that because it is they are connected, so they will move with the same acceleration. So we can use this equation of motion 2as is equal to v square minus u square for the height there, where it is 2, acceleration is 4, height is h, v square is 2 square minus 0 square. So that is equal to 8h is equal to 4, or h is equal to 4 over 8, and that is equal to 0.5 meter. It is at a height of 0.5 meter above the ground of this particle Q there. So this is the first part of this question there. Then they are asking find the value of M and the tension T there. So we know that, let's say that is the tension T, which is equal in magnitude but opposite in direction. And they have mentioned it there that P is moving upward and Q is moving downward. And we know that from the second part, the driving force minus resistive force is equal to MA. This is the equation we are going to use it for this motion there. For this particle P, This is the particle P. Its weight is acting downward there. So it is mg, and that is tension T there. So it is moving upward. So the equation of motion will be driving force is T minus weight is mg is equal to ma, or T minus mg is equal to 4m, because acceleration is equal to 4. We have calculated it in the first part of that when we are going to calculate the height of this object there. Then for the particle Q, it is coming downward. So its mass is basically 1 minus m into g. So that is the weight of the particle Q there. So again, we can use this equation of motion that driving force minus resistive force is equal to ma. So the equation will become 1 minus m into g minus t is equal to 1 minus m into a. But a value is equal to 4. So 1 minus m into g minus t is equal to 1 minus m into 4. Let's say that is equation number 2 there. Now we are going to calculate the value of T and M from these two equations. So it will be equal to T minus mg is equal to 4m, and this is 1 minus m into g minus t is equal to 1 minus m into 4. So if we add these two equations 1 and 2, then this plus t is cancelled by minus t, and it will be left there 1 minus m into g minus mg is equal to 4m plus 4 minus 4m. So that is equal to g minus mg minus mg is equal to 4m plus m minus cancel. So it is equal to 4. So minus 2mg is equal to 4 minus g, or minus 2m, g value is 10 there, is equal to 4 minus 10. So minus 2m into g is 10 there, that is 6. So m is equal to 6 over 20, or that is 3 over 10, or that is value is equal to 0.3. So this is the value of m. We have calculated it in this part. So if m is 0.3, then we are going to find out the tension T. So we can use any one of this equation 1 or 2 there. So this equation number 1 says that tension minus mg is equal to 4m. So T is equal to mg plus 4m. So m is common there. It is g plus 4. M is 0.3. G is 10. It is 4. It is 0.3 into 14. And that is equal to 4.2 newtons is the tension of that string in this question there. Then in the last part, when Q hits the ground, the particle P is moving upward. Find the time it elapses after, again, the string becomes taut. The string becomes taut for that part is like this. If this is the initial position of P, it is the new position of P after covering a distance of 0.5 meter from the ground, and then at this point it comes again upward with the inertia, and that is point p double dash there. So this height is already known to us, that is 0.5, and you know that time taken from this point to p dash is 0.5 seconds, because this is the time that is being mentioned there. It is taking 0.5 seconds to reach from p to p dash. Then at p dash, the sting becomes slack. Slack means what? When the tension is equal to 0. And then the particle is going to move under the inertial forces from p dash to p double dash. And let's say at that point p dash, the velocity is 2 meters per second, as it has given in this point there. Now this velocity v is becoming u there, which is 2 meters per second. But when it will reach at the highest point to that, then when the q hits the ground, then this particle has the velocity 0 there. And you are going to find out the time for this portion there. We know that because it is moving upward. So v is equal to u minus gt. V is 0, u is 2 there, minus g is 10 into time t there. So time t is equal to 2 by 10, and that is equal to 0.2 seconds. So it is the time when it's going to reach at the point p double dash. So that is 0.2 seconds to reach from p dash to p double dash. So when it will be at the highest point, again it will come downward. So this is the motion of that particle p, that it is coming again downward at this position there. So the time is has taken up till to the highest point, that is 0.2. So the same time is will be taking in the downward motion, that is equal to 0.2 seconds there. So it means the particle p is going to take the total time there is, first it is 0.5 seconds, and then it is 0.2 plus 0.2, because you are going to find out the height of that particle there. So that is equal to 0.9 second is the time when the sting becomes taut again from the height of the ground there. So this is a solution of this third part of this motion of the two connected particles p and q. And in this part, they said that when the string becomes taut, so 0.2 seconds it will getting upward, 0.2 seconds is getting downward. So this is total time in the air of that when the q hits the ground. And because we are going to find out the height from the ground, so it is 0.5 seconds already it has taken there, and this is 0.4 seconds. So its time will be equal to 0.9 seconds there. Now, question number 7. A small ring R is attached to one end of the light inextensible string of the length 70 centimeter. A fixed rough vertical wire passes through the ring R. The other end of the ring is attached to the point A on the wire vertically above R. A horizontal force of magnitude 5.6 Newton is applied to the point J of the ring, which is 30 centimeter from A and 40 centimeter from R. The system is in equilibrium with each of these parts AJ and JR of the string being taut, and the angle AJR is equal to 90 degree as shown in this diagram. Find the tension in AJ part and tension in the JR part. So first we are going to calculate the angles, and then we will find out the tension. So we have seen it there that it is 90 degree there. So if we make that one a triangle there, where this is the point 90 degree at this point, and this is R, and this is A. AJ is equal to 30 centimeters, and RJ is equal to 40 centimeters. And we know from this Pythagoras theorem that this will become 30 square plus 40 square root, and that thing is equal to 50 centimeter of this A to R length here. Now, if this is angle theta 1 and this is angle theta 2, so theta 1 will be calculated as it is, perpendicular over hypotenuse. So that is sine of theta 1 is 30 over 50, or that thing is equal to 0.6. Similarly, theta 2 is being calculated as sine of theta 2 is equal to 40 over 50, or that is equal to 0.8. So these are the values of sine theta 1 and sine theta 2 there. Now, you have to find out the value of the tension in the strings AJ and RJ. Again, we will solve this figure. This is the horizontal force acting on that one. That is 5.6 Newton in this direction. And this is the tension TA, and this is the tension TR, because one is going to be presented by A particle and one is going to be presented for this R particle there. Since at the point theta 1 is at the point R, so this angle is equal to theta 1 and this angle is equal to theta 2 there. Now, if we resolve this force into components, then this will be TA. If this angle is theta, two, and this angle they have mentioned as theta 1. So according to this is perpendicular. So it is TA sine theta 2, and this will be TA cos theta 2. Similarly, this angle is theta 1. So if we solve it, so this component will become TR sine of theta 1, and this component will become TR cos of theta 1. Since the particle is in equilibrium, so all horizontal forces are balanced there. And their horizontal force 1 is there, is TA sine theta 2 plus TR sine theta 1, and that is equal to 5.6, because the rightward forces are balanced by the leftward forces. TA we don't know, but T sine theta 2 is there, equal to 0.8. TR we don't know, and sine of this portion is 0.6, and that is equal to 5.6. Let's say it is equation number 1. The second equation is for the vertical forces, because they are also balanced. And here the vertical force upward is TA cos theta 2, and that is balanced by TA cos, sorry, it is TR cos theta 1. So TA we don't know, but if we know from this property that sine square theta plus cos square theta is equal to 1. So we can use for this first part sine square theta 1 plus cos square theta 1 is equal to 1. But sine square theta 1 is 0.6, so it should be equal to 0.6 square plus cos square theta 1 is equal to 1. So cos square theta 1 is equal to 1 minus 0.36, or that is 0.84. So 0.64. So cos of theta 1 is equal to 0.8. Similarly, sine theta value there is again sine square theta 2 plus cos square theta 2 is always equal to 1. But sine square theta 2 is equal to 0.8 plus cos square theta 2 is equal to 1. So cos square theta 2 is equal to 1 minus 0.64, that is 0.36, or cos of theta 2 is equal to 0.6. Now we put the values of these two into this equation. So cos of theta 2 is equal to t into 0.6 plus is equal to tr into cos of theta 1 is equal to 0.8. So you can write out TA is equal to tr into 0.6 over 0.8 over 0.6. So that is equal to 4 over 3 tr. Now we put this value into this equation number 1. TA into 0.8 plus tr into 0.6, that is equal to 5.6. But TA is equal to 4 over 3 tr into 0.8 plus tr into 0.6, that is equal to 5.6. So tr is common. It is 4 over 3 plus 0.6, that is equal to 5.6, or tr is equal to 5.6 over 4 over 3 plus 0.6, and that value is equal to, sorry, now we can put the values into this. So 4 over 3 into 0.8 tr plus tr into 0.6, that is equal to 5.6. If tr is common, it is 4 over 3 into 0.8 plus 0.6, that is equal to 5.6. So that is tr is equal to 5.6 over 4 over 3 into 0.8 plus 0.6, and that value is equal to, so it is equal to 3.36 Newton. When M is 0.2 kg, you are going to find the friction at the particle R there. So this is R at this position, whose weight itself equal to 0.2 mg downward, plus there is a frictional force acting on that particle downward. Then there is a normal reaction R1 perpendicular to that surface, and this is the component T R cos of theta 1 it is upward, and this R1 is being balanced by TR sine of theta 1. And since the system is in equilibrium, because this is the way that this is the TR force now, because it is moving in this direction like this. So because the system is in equilibrium, so driving force minus the resistive force is equal to the net force MA. But we know that the acceleration is equal to 0 because it is in equilibrium. So driving force is equal to the resistive force. And here the driving force is TR cos theta 1. That is being balanced by weight plus friction. So weight is basically mg plus friction is mu r1, that is TR cos of theta 1. But TR cos of theta 1 so it should be equal to TR cos of theta 1 is equal to mg plus mu, and R1 is being balanced by TR sine of theta 1. And now we put the values into this part where TR cos of theta 1 so TR and cos theta 1, TR there is equal to 3.6 into so it should be equal to 3.36 into TR is equal to 0.2 into G is 10, mu is unknown, TR we have already calculated, and sine of theta 1 is equal to 0.6. Cos of theta 1 is there equal to 0.8 there. And from this, we have got the calculation there. TR value is equal to 3.36 into 0.8 is equal to 2 plus mu into 3.36 into 0.6. So mu value is being calculated there equivalent to 0.341. That is the coefficient of friction between the two particles there. And now in the last part, given that the coefficient of friction is unchanged and a particle of mass m kg is attached to this R. Now find out it is on the point of the moving down the wire, find the frictional force of that particle there. If the particle m is attached with the ring and the point is slipping is downward. So the last part of this one is, if this is the ring whose weight is acting vertically downward, that is mg, that is 0.2 g, because that is the mass of the ring there. And there's a further force of weight mg is attached to that. So it is coming downward to that. Then the frictional force is upward and the tension is also upward, which is basically equal to TR cos of theta 1, that is both upward there. Since here it is the normal reaction R, which is being balanced by this force, that is equal to TR sine of theta 1. And since frictional force is basically equal to mu R1, so it should be mu, and R1 is basically equal to TR sine of theta 1. So by using all this information into this question, we are going to find out the value of m there. So since it is in equilibrium, so driving force is equal to the resistive force. And the driving forces are there is T mg plus 0.2 g. This is the driving force of this particle. Because this is coming downward, this is coming, trying to move it downward there, which is being balanced by TR cos theta 1 plus F. So TR cos theta 1 plus F. But F is basically equal to what? Mu R. So it is equal to mu into TR sine of theta 1. So M is common there. M into G is 10 plus 0.2 into 10 is equal to TR cos theta 1 plus mu is the same, which is equal to what? 0.341 in the previous part, because it is unchanged, and TR sine theta 1 is there. So TR cos theta 1 plus mu into TR sine theta 1. So this value is known, this value is known, this is known, this is known, this is known, and this is unknown there. So only m is going to be unknown there, where the rest of the values are known to you. And now you can calculate the value of m there, which is equivalent to so m value is equal to 0.137, which is supposed to be calculated in this part there. So this is when the downward motion is there. this still is in equilibrium, so the frictional force acting upward now. And this component are driving resistive forces, this and this component, they are driving forces. So by this calculation, we have done this value of m there, which is equal to 0.137 there. So that is the last question of this 7 of this paper 2015 for this mechanics one.